Hello and welcome students. Today we are going to see how to do the topographical measurement using the total station. In the last video I have discussed about the basic things about the total station. So that was the introductory video. Now in today's video we will see how to do the actual topographical measurement using a total station. So before proceeding to the actual measurement, I will show you the target and the prism. Okay students, so this is my target. Okay, this is my target, and at the top of the target the prism is fitted. So this is our prism. So this will give you the reflection of laser beams. This is my prism. Now whenever we are doing a total station survey, we need to mention the target height. We need to mention the target height, and that target height is not fixed one, that we can change according to our requirement. So we will see how to change the target height first. So this is the knob which is provided to this target. So by pressing this knob, one can change the height of the target. In a closed position, when it is a closed, when it is a closed position, then the target height is a 1.5. The target height is a 1.5, and I'll show you how we can change it. So you just press it, this knob you need to press it, and after pressing just lift it. Press so this. Now it is changed. Now you can see the mark 1.65. so this is my now new target height. So according to the visibility of target, we can give the input to the total station regarding the target height whenever we are changing. So right now it is 1.65. so I'll press it. When I press this knob, this will go down, and again it will become 1.5. Now it is 1.5. so I'll keep a target height as a 1.5. I'm not going to change, so I'll keep it as it is 1.5. Now we will see that how to create a job in the total station, a new job. And subsequently we'll see how to give the inputs to the total station, and how to do the topographical measurement using the total station. As usual, every equipment needs a temporary adjustment when we are establishing any surveying equipment at a new station. So this also needs a certain temporary adjustments. So what are these temporary adjustments? These are similar to a digital theodolite or a conventional theodolite. So I'm not going to discuss about the temporary adjustment, because already we have discussed in our previous video on the digital theodolite. So you can refer that video. I'll share that link, so you can go through that video to see how to do the temporary adjustments of the digital theodolite, and similar are applicable to the total station. Now the only important thing about this equipment is this equipment, or this total station, has an electronic level. So to see the electronic level, you can press this tremble key. In a tremble key, select electronic level, and you will get this type of the electronic level. So in the both direction you will see the spirit level is at a center. So this way also you can do the leveling of the total station. So I have done all the temporary adjustment for this equipment, that is fixing on a tripod stand, then a leveling, and centering, everything is done. Okay, so this is your optical plummet. This is my optical plummet. With the help of optical plummet, you can check the center of the equipment. Okay, you can check the center of the equipment. So after doing all the temporary adjustments, you can start the actual measurement. That is, first we need to do the first we need to create a job. So we will see how to create a new job in this equipment. So first we will create a new job. So for creating a new job, you need to press the menu key. In the menu key, go to the job manager, then go to a new job, press enter. Okay, here you can give a job number according to your wish. So what I'll do, I'll give a job number as a date. Okay, what is the today? Today is just a minute. I will give the today's date. So from here you can change to alphabetical keyboard to the numerical keyboard. So here with the help of your phone key you can change. So I'll make it numerical key. So what is today's date? No, let's see, just a minute. 12/05/2021. Okay, then angle unit, degree, minute, second. So I'm not going to change all these settings. Is it direction, distance unit, coordinate system, coordinate display. First northing will be displayed and then easting will be displayed. Temperature units, the pressure unit, scale I'm keeping as 1, curvature and refraction correction, sea level correction is on. So all these settings we are keeping as it is. Then to go to the next page you can press this F4 key. Okay, and to create, it is saying press F2. Okay, so I have created a new job. So job is created, our job is created. Okay, so this is my new job. Now before proceeding to the actual topographical measurement, I need to tell this equipment what is the coordinates of the center of the equipment. So let us assume somewhere here is a center. Okay, and what is the coordinates of this center, right? At the same time I need to tell what is the reduced level of this, what is the reduced level of the center of this equipment. Okay, these two things I need to define, or I need to tell the equipment. Okay, that is defining the coordinates of this station, defining the elevation of the station. At the same time I need to define where is my north direction. Okay, where is my north direction? Now this equipment doesn't have any a prismatic compass or compass, right? So I cannot find out the north direction. Either you can take any permanent object as a arbitrary reference point, or what you can do, before starting of the total station surveying, you can establish any prismatic compass or any equipment which can give you the north direction, that you can establish. First find out the north direction, fix the ranging rod at the north direction. Okay, or what you can do, select any permanent object in the vicinity of your site and try to find out the bearing of the fixed points. Okay, you can find out the bearing of the fixed points and you can give the bearing. Okay, you can give the bearing of that fixed point as a reference, okay, as a reference point, right? So what I have done, I have fixed this, instead of a ranging rod, I have fixed this target, okay, as a reference line, okay, as a reference line. I have fixed this target as an arbitrary reference point. So we will take this prism or the target as a reference line. Okay, let us see how to give the inputs to the equipment, okay, and then how to start the topographical measurement, that we'll see. So press a menu key, okay, press a menu key. In the menu, go to the coordinates. In a coordinates, there are two methods. One is a resection method, one is a known station. There are two methods through which we can give the coordinates to your station. So I'm selecting a known station. That means I know the coordinates of this station. Okay, I know the coordinates of this station. So I am selecting known station. Okay, so known station is selected. Whenever you are selecting known station, this type of figure will get displayed on the display screen. So this figure is a self-explanatory. It's a very important. This is very self-explanatory. So what it is telling, S is my station. S is my station and A is my reference point. Okay, A is my reference point and the bearing of this A is calculated. Okay, a bearing of this A is calculated, which is with respect to the north. Okay, in case if you are not interested in this north direction or something, then you can directly skip that and you can directly select this A as a direct reference point or A as a 0, 0 point. That you can do. Okay, but here what we'll do, we will assume our reference point has a bearing of 30 degree with respect to the north line. So whatever the reference point, this is my target, okay, which is my reference point for this movement, and the bearing of this reference point is a 30 degree, means the angle of this reference point with respect to north is a 30. So what I'll do, I'm going to insert this data to my equipment. So first I will give the station coordinates. So for that purpose I'm pressing S, okay, yes. For S the F1 key is given, so yes. Then you can call, or you can take the data from internal memory, or you can give the inputs. So I'm giving the inputs. So what I'm doing, I'm selecting the coordinates as an 400 northing, 500 easting. Okay, so coordinates are given to the equipment. Now here, okay, here you can do the backsighting. That means the reference point you can define, or reference direction you can define by the two methods. One by giving the angle with respect to the north line or any arbitrary line, and other method is giving the northing and easting. Okay, now this function, so giving the northing and easting, that we can use when we are doing the change point. That means whenever I am doing a change point, okay, when I will shift my equipment to the new station, so from the new station, when I am doing the backsighting on the previous station, at that time I can use this northing and easting function, that is F4. But right now this is my first station. So what I'll do, I'll use AZ. What is the angle with reference to the reference line. So as I told you, let us assume we have measured the bearing of the reference point with respect to the north, and it is a 30. Okay, now what this equipment is saying, first, okay, this is first target, Okay, target your telescope to the reference point. It is clearly mentioning, it is giving you the instruction. Okay, target your telescope towards the reference point and then enter, continue with the measure and enter. Okay, then press measure and enter key. So what I'll do, I will sight towards my reference point. So this is my reference point. Can you see this? Okay, this is my reference point. So first I'll try to see through the target shoots. Okay, first I'll try to see through the target shoot. Can you see this white triangle in the target shoot? Okay, so bisect your target with the help of this target shoot and then look through the telescope. Then look through the telescope and use this focusing screw to focus exactly. Okay, so let me do that. Yes, so I have perfectly bisected my target. Okay, I have perfectly bisected my target. Okay, can you see this prism? Okay, and my telescope is sighted towards that prism or the target. Now what we will do, we will press this measure and enter key. Just press the measure and enter key. So you will see the northing and easting 400 and 500. Okay, OM is a orientation circle. Okay, just press yes, so it will get recorded. So what we have done right now, we have given the coordinates of my station to this equipment, and then I have defined the reference direction, or rather I have told the equipment this is your reference direction. Okay, this is your reference direction. So that information we have given. Now the next thing is, we need to give the information regarding the what is the elevation of your station. Okay, what is the elevation of the station? If you know the station elevation, there is no problem, you can directly give the input of station elevation. But let us assume I don't know what is the elevation or what is the reducer level of my station. So I need to find out the elevation or the reducer level of the station. So for that purpose you can use this station elevation function. Okay, you can use the station elevation function. So with the help of station elevation function, we can take the reference of benchmark, and from the benchmark we can find out the reduced level of this point. So let me put the target at the benchmark, then we will see what is the procedure. Now we will see how to give the inputs to this equipment, how to give the different inputs to this equipment to find out the station elevation. So I have assumed a benchmark. Okay, and on that benchmark I have kept my target. You can see clearly this target, and let us assume the reduced level of target, or sorry, reduced level of benchmark as 100. Okay, so back to equipment. So press enter key, go into the station elevation and then press enter key. Okay, then press the enter key. Okay, now so this is giving you a self-explanatory diagram. IH is the instrument height, TH is the target height. So obviously target height or target will be kept on a benchmark. So Z is my benchmark. Instrument height, so we are going to find out ZS. So I am interested in a ZS. Okay, or rather I want to find out the elevation or the reduced level of my station. So these three data we are going to give: Z, benchmark, reduced level, target height we have kept as 1.5. Instrument height, yes, we are going to find out just with the help of a normal tape. Measure what is the height of your instrument from the ground. and then all this data is given to this equipment and we will get a ZS. So let us measure what is the height of the equipment. So this is a cross mark. Okay, this is the cross mark on this equipment, okay, on a vertical circle, which represents or which tells us where is the center of your telescope or the horizontal axis along which your telescope can be rotated. So I'm using a tape, a measurement tape, and I'll see what is the height of the instrument. So how much? Here it is 130, 140, 141 point. It is around 1, 2, 3. Okay, 1.413 or 1.41 we can call. 1.41 is the instrument height. So that we are going to enter into. So this height we will enter. Okay, so one by one we will enter all the data. Okay, we will enter the data. So for that you need to press the start, then input. Okay, Z, as I told you, Z is a benchmark, so I'm giving the reduced level of benchmark as 100, reduced level of benchmark as 100, then press enter. Instrument height, it come to be 1.413. so instrument height is given. Then it is asking what is the target height, that is 1.500. okay, so this is my target height. So all the data is given. Now this equipment will tell that target your telescope towards the benchmark and then press the measure or enter button. So we'll do that. So just loose the clamping screw, again use the target shoots. Okay, use the target shoots to target. Can you see this, the prism and the target? So I'm trying to match this triangle, okay, to this target, and then look through the telescope and then press a measure and enter button, then press this measure and enter button. Okay, so what I have done, I have looked through this target shoots towards the target first, then looked through a telescope perfectly bisected and kept my crosshairs exactly over the prism, and then I am going to press this measure and enter button. Okay, I'll press this measure and enter button. Now you will see, okay, ZI, IH and ZS. So ZS is my station's reduced level. ZI is my reduced level of collimation plane, reduced level of my collimation plane, and IH is my instrument height. Okay, so I am going to save this data, so it is recorded now. So what are the steps that we have followed? We have given the coordinates through the known station. We have told equipment where is my reference direction. Then we have determined the station elevation. Now we will go into the major topo. So when you press the major topo, okay, when you press the major topo, whatever the information that we have given to the equipment, that will get displayed once again for checking purpose. The northing and easting we have given as a 400 and 500. Is it okay? Yes. Then horizontal angle, okay, actually this reference direction that we have already given, yes, it is okay. Why it is okay? We have given 30, but it is now showing the 12 degree or something, because I have moved my a telescope, so that's why it changed. So it's no problem. Instrument height is 1.413 and Z is the right now that we have calculated 99.536. Yes, it is correct. So everything is correct. Now we are ready. To start the topographical measurement. Now what you need to do, just take your target, keep your target at a point whose northing, easting and the elevation you wish to find out. Okay, the point whose reduced level and the coordinates that you wish to find out, keep your target at that point. Okay, and then just click on the measure button. Okay, click on the measure button. But sometimes, let us assume, in between, if you wish to change the target height, okay, then just press the trimble key. Okay, then just press the trimble key, go to the target. Okay, go to the target, and from here you can either select any target height which are previously saved, or you can edit with the help of F2 button. Okay, so that can be done at any point. Okay, now what we'll do, we'll try to find out the reduced level of the one of the point, 1 or 2 points. So this is my point, 1 point I have selected, and I'm going to find out the coordinates as well as reduced level of this point. So again the same procedure. So when you are using this target shoots for the approximate bisection of your target, okay, once it is approximately bisected, okay, then you can use this a clamping screw to clamp, okay, to clamp the horizontal circle so that it will not move, and then look through the telescope, then use the focusing screw and focus. Okay, and when it is perfectly bisected, yes, you are going to press the measure and enter key. Okay, I'm going to press this measure and enter key. So these are the coordinates of the point and the elevation of that point. So this type of the data I'm going to get for the every point. Now if you remember the previous video, in that we have discussed many setting and everything. So if the record mode is a confirm, okay, if the record mode is a confirm, it will ask me whether to save this data or not. So every time you need to save this data by pressing S button. If I select recording as all, so in that case it is not going to ask you whether to record or discard, it will directly save. But as my record mode is a confirm, so it is asking me whether to save or discard. So I'm going to save this. Okay, now you can move ahead with the next point. So I have selected one more point. Okay, I have selected one more point. So you can see this a target, and the same procedure I'm going to follow the same procedure, okay, that we have just discussed, and then we'll try to see what is the coordinates of this. So I have sighted towards this point. Okay, then focusing and everything is done. Now I will be pressing and press this measure and enter button. Now you can see the change in the Z 100, right? Reduced level is now increased, and northing and easting. So all this data, or this type of the data, we will get for the every points. And whenever you import this data to the any software, okay, whenever you import all this data to the any software, you can easily do the further processing. Okay, so that we will try to see in a subsequent videos. So this was about the topographical measurement using the total station.